Which sample contains the greatest number of atoms? Okay, so let me write this down here. Oh, there we go. That works better. This was question 4, I believe. Yeah, that's question 4. Oh, I don't want that. Decrease this here. It's got a bit thick. Okay, so which sample contains the greatest amount of atoms here? So A here is we have 14 grams of carbon. B is we have 49 grams of Cr. C is we have 102 grams of silver here. And D is we have 202 grams of lead here. And it's asking us which sample contains the greatest amount of atoms. So we have grams here. What we want to do is we want to solve for the number of atoms, right? So in order for us to do that, we're going to have to find our moles first, and then what we can do is we can multiply by Avogadro's number, because that's going to give us the number of atoms in the sample here. So let's divide here. I want to find moles of everything, right? So again, moles equals mass over molar mass. So we're going to divide all these guys by the molar masses here. So therefore, I'm dividing this by, again, the molar mass of carbon is 12.011 grams per mole. Chromium is going to be 51.996 here. So 51.996 grams per mole. Silver is going to be 107.87 here. And finally, lead here is 202 PV here, 202 grams, which is 207.2 here. So this is going to be 4 values here. So we do this, do those operations with the calculator. So 14 divided by 12.011. It's going to be a value of 1.1656. I'm going to take 4 decimal places. 49 divided by 51.996. It's going to give us 0.9424. I have 102 grams divided by 107.87. It's going to give us 0.9456. And then I have 202 divided by 207.2 here. It's going to be 0.97. 4 moles. So right off the bat here, I can actually figure out which sample has the greatest amount of atoms, and it's going to be the carbon here, because it has the most amount of moles. And what we're doing, and why we know that, is because we're going to multiply all these guys by Avogadro's constant. So I'm going to multiply all of these guys by, or let me simplify this. So multiplying all of these guys by, this is 6.02 times 10 to the 23, right? And this is atoms per mole. So if I multiply all of these guys here, basically I'm going to get the value which is going to be the number of atoms, right, for all of these guys here. And if I were to do this that operation, I'm multiplying by the same number for all of these guys. Obviously, the biggest number is going to be would have the greatest amount of atoms here. So A here is going to be our answer. And if I do that operation for you, so I have 1.1656 times 6.02 times 10 to the power of 23, I'm going to get carbon is going to have 7.02 times 10 to the 23 atoms, and you're going to figure out that this here is the greatest amount of atoms for these samples, even if you multiply these guys here. So copper will have the greatest amount of atoms here. I believe that the solution is missing some type of it's missing basically the equation, the numbers here. So I'm going to write that down for them as well. So to figure out the number of atoms in the sample, we will have to divide the masses of the sample by their respective molar masses. So I'm going to have 14 grams of carbon divided by 12.001 grams per mole, going to equal 1.1656 moles here. B is at 49 grams of Cr divided by 51.996 grams per mole. Give us 0.9424 moles. C is 102 grams for silver divided by 107.87 grams per mole. Give us 0.9456 moles. And D is 202 grams for lead divided by 207.2 grams per mole, which give us 0.9749 moles here. And as you can see, A contains the most amount of moles. So therefore, when we multiply all the options by Avogadro's number, is it AVO? I think it's AVO. Avogadro's constant to solve for the amount of atoms. A will contain the most amount of atoms in the sample. Therefore, and I'm going to solve for specifically this one here. So 1.1656 moles multiplied by 0.02 times 10 to the power of 23 atoms per mole will give us our value of, what did I solve for here? This is 7.02 times 10 to the power of 23 atoms, carbon atoms. So therefore A is the correct solution. So I'm going to say solution is incorrect because it's just incomplete here, as well as the solution here is incorrect.